This is a video from the Exam 2 Review Part 1. I want to introduce you to some notation first. Capital C followed by the closed interval a to b is equal to the set of continuous functions on the closed interval ab. And with that, let's take a look at 10. Let w equal the set of all continuous functions f equals f of x on the closed interval a to b, such that the integral from a to b of f of x dx is equal to 0. Show w is a subspace of the set of continuous functions on the closed interval a to b. Now, h of x equals 0 is continuous on the closed interval a to b, and the integral from a to b of h of x dx is equal to the integral from a to b of 0 dx, which is equal to 0. Therefore, h belongs to w, and we can say w is non-empty. Now, let f and g belong to w and let k be a scalar. We want to show that f plus g and kf belong to w, right? So in other words, we want to show f plus g belongs to w, that's closed under addition, and kf belongs to w, that's closed under scalar multiplication. The sum of two continuous functions on the closed interval a to b is continuous on the closed interval a to b. So we can state that from calculus. A scalar multiple of a continuous function on the closed interval a to b is continuous on the closed interval a to b, and that's also from calculus. And so, therefore, f plus g and kf are continuous on the closed interval a to b. Additionally, if I take the integral from a to b of f plus g of x dx, and by the way, we need to state this first. We're taking the integral from a to b of f plus g evaluated at x dx. That's our new function. But from the algebra of functions, we can write this as the integral from a to b of f of x plus g of x dx. From calculus, we can break that apart. That's the integral from a to b of f of x dx plus the integral from a to b of g of x dx. That's equal to 0 plus 0, which is equal to 0. And so what that tells me is that f plus g belongs to w, and w is closed under addition. Now, if we look at the integral from a to b of kf evaluated at x dx, but by the algebra of functions, we can write this as the integral from a to b of k times f of x dx. But I can pull the k out in front of the integral from calculus, and we can write this as k times the integral from a to b of f of x dx, and this is equal to k times 0 since f belongs to w. But that's equal to 0. And so that implies kf belongs to w, and we can therefore conclude that w is a subspace of the set of continuous functions on the closed interval a to b. And that's a good stopping point for this video. This is a video from the Exam 2 Review Part 1, Problem 10. Thank you.